Good morning, teacher and partners. My team is going to present the topic of the Fourier Transform. And my team is formed by Elias Mokshe, Oscar Chan, Antonio Gonzalez, and me, Brano. Uh, now, I'm going to explain what the Fourier Transform is. The Fourier transform is fundamental mathematical operation for some disciplines, such as telecommunications and physics. Without it, modern telecommunications would not exist. Not only the internet of mobile telephony, but also conventional telephony itself, which would not have been able to evolve beyond a form of local communication. Along distance, would not have existed. Okay. Although this mathematical operation owes its name to the mathematician Joseph Fourier, the truth is that many have contributed to his invention, including all Bernoulli, Lagrange, and Gauss. Fourier played an essential role in inventing the Fourier series, where a periodic function could be decomposed into the sum of trigonometric functions, and the Fourier transform generalizes this concept.
Now, my name is Antonio, and I'm going to explain the uses of Fourier transforms. The Fourier transform is an indispensable mathematical operation for many disciplines. It's used in fields such as medicine, telecommunication, acoustic engineering, electrical circuits, bridge design against resonances, and audio track compression, among others. It also plays a very important role in the PDI. Since it is a tool that allows use to obtain the representation of information in frequency space, and by applying an operator in this domain, we can operate on the image to detect and enhances edges, eliminate noise, etc. In it, interactive whiteboard, also known as PDI, is a technological system generally consisting of a computer or projector and pointer control device, which allows projecting on an interactive surface digital content in a format suitable for group viewing. In communication, is used to analyzing signal frequencies, design signal transmission systems to transmit information chains that occur as signals travel. In mechanical engineering, is used to study problems related to mechanical vibration in motors, generators, and rotating equipment in general, and designs systems to absorb vibration and eliminate their effects. And the last in electromechanical field is used to serves to solve partial differential equations with boundary conditions to determine the distribution of electromechanical fields in each space. Now I'm going to my partner continue.
Going to explain the Fourier transform formula. The Fourier formula is considered to be a formula with infinite limits. These equations allow us to calculate the frequency domain expression expressed with a FW when we know the time domain expressed with a FT. The domain of a function is the set of values that the variable can take. The set of sources values for which function will return an output or another value. When it is the time domain, the source values are time values. For example, 2 seconds, 7 seconds, 1 minute, 2 minutes, etc. And the function in the time domain would be expressed with AFT. When we talk about frequency domain, the source values are frequency values. For example, 7 radians per second, 100 multiplied p radians per second, etc. Or it can also be a frequency expressed in cycles per second or hertz. And the function in the frequency domain would be expressed with a fw. For example, given a function that tell you how much of a magnitude there is at each instant of time, the transform giving you another function that tells you the amount that the previous function has at each frequency. Uh, as you can see in the animation, you can see the original signal with a f in the time domain, usually expressed with a ft, is decomposed into a sum of sinusoidal type signals of pure frequencies, and the blue graph is the transform, which indicates the coefficient of each frequency. In the presentation, you can see two formulas. The formula in the left is the Fourier Transform formula, and the formula in the right is the inverse of that. And the inverse formula allows us to find the ft if we know the fw, and the Fourier formula uh, we can find the fw if we know the ft. The value of the w, the w is the omega, and it is equal to 2 multiply the t multiply the f. We can integrate the Fourier formula, that is fw equal to infinite limits positive and negative ft multiply the e over minus ewt derivative, and this could be equal to minus p over 2, and at the top p over 2 e over minus ewt and the derivative of that. And in the bottom of the presentation is the integral of the second part, that is 1 over minus EW multiply the E over minus EWT with a limit of P over 2 and minus P over 2, and it could be equal to 1 over minus EW multiply the E over EWP EWP over 2 and minus E over AWP over 2. That's all for me.
Of the extent of the application of the Fourier transform, we have if of t equals to 5 times e to the minus 3 times t minus 2 squared. According to the Laplace transform, we have that e to the minus a times t squared guide of the Fourier transform is the rod if p between a times e to the minus omega squared between 4 times 8, but since we have t minus 5, this indicates that there is a shift in time. So we take the transform of 5 times e to the minus 3 times t squared only. That will be left which 5 single the constants are maintained, so it will be 1 times the rate of p divided by 3 times e to the minus omega squared divided by 12. Note, all that remains if they have the Fourier transform of the function, so we must multiply the previous resultant with tan times which of the we can T sub 0 is 5. So it will be what E as 5 times to 5 times the root of 5 divided by 3 times e to the minus omega squared divided by 12 times the shift that will be e raised to the minus 5 e times omega, and with this we will have the Fourier transform.
Is something that is used for in every thing that we use in our life. For example, in the telephony, digital music, and some digital assistant, for example, Siri, Alexa, and Google Assistant, and other voice recognition systems, electrical circuits, bridges, heat studies, etc. This formula has many applications on every time of our life.